To do a quick video to explain what a radian is, because sometimes there's some confusion with this different measure of an angle. So that's exactly what a radian is it's a different way to measure an angle. You're used to measuring angles in degrees, like if you have a 30-degree angle. Well, there's actually another type of unit called a radian, much like, you have inches and feet in the standard system, and then you have meters and centimeters in the metric system. They're just different systems, but they measure the same thing, just with different units. Well, a radian is actually just a unit of measure of an angle. So here's how I want to set this up. Let me help you understand what a radian is, or how it's defined first of all. So if we have an angle, we might call that, I don't know, maybe it's 50 degrees or whatever the heck it is, but we're going to define a radian a very specific way, okay? So if we have a radius of r, and then we travel around the outside of the circle, which is called, of course, the circumference, right? Well, we don't go all the way around. We only go a distance of r. Then this would be 1 radian. That's how we define this. So if I draw it again here, maybe this is like 4 inches. So if this is 4 inches, then we've just found 1 radian. So if the ratio of the arc to the radius is 1 to 1, then you've just defined 1 radian. Now, what if I go, let's say 8 around. So the radius is 4, and let's imagine that this arc length is 8. How many radians would that be? Well, this would be 2 radians. That'd be 2 radians. Now, let's start thinking about this all the way around the circle. All the way around the circle is called the circumference, and circumference is 2 pi r. So the number of radians is the arc length divided by the radius. Arc length divided by the radius. So if we go all the way around the circle, we've traveled 2 pi r. And what happens if we divide by the radius? We get 2 pi, and that is the radians for going all the way around a circle. So here are some of the conversions that I'd really love for you to memorize, and they have to do with the fact that all the way around the circle is 360 degrees. All right, down here, let's write a couple conversion factors that are really important to remember. So I mentioned just a moment ago that all the way around the circle, that's 360 degrees, is 2 pi radians. So that's something you probably want to just memorize and know. So that also means, by the way, that 180 degrees is 1 pi radians. So you might want to memorize that too. Now, of course, they're kind of the same thing, right? Pretty easy stuff. So how do we convert from one to another? Like if we have 50 degrees, how do we figure out how many radians that is? Well, there are these conversion factors. So if you are converting from degrees to radians, you multiply by the fact that pi radians is the same as 180 degrees. And if you're converting from radians to degrees, then you multiply the radians by 180 over pi. I'm going to show why these are the conversion factors also, because we're going to show some work. You probably remember in an earlier math class that you did a thing called unit analysis, where you made sure that the units cancel. That's the way I like to think about this. So 60 degrees is what I'm given, and then I'm going to multiply by a conversion factor. And I want the degrees to cancel and leave me with radians. So the degrees have to go on the bottom. You see, I like to say the units drive the problem when I'm doing unit analysis. So that must mean the radians go on top. And look at this. The unit degree cancels because we've got a degree on the top and the bottom, leaving our unsimplified answer 60 pi over 180. Now, of course, both of these divide by 60, so you can reduce the fraction down to, this would be pi over 3. So you might want to memorize that 60 degrees is pi over 3, because remember, that's one of our reference angles from our 30-60 triangle. 60 degrees is pi over 3, and 30 degrees is pi over 6. So you may just want to memorize those. So let me write that one down also. So 30 degrees is pi over 6 if you do the conversion like I did below. Okay, let's try another conversion. 120 degrees negative. Negative angles, of course, just mean you go clockwise around the grid. So we put down the given information, which is negative 120 degrees. We multiply by pi over 180, because remember, I want the degrees to cancel, so the 180 has to go in the denominator. That's how I remember this. I don't necessarily memorize, per se, these two things. I just think about the units canceling, and then I just don't have to memorize things. I just understand that this is what we have to do to cancel the units, and we get negative 120 pi over 180. That is negative 2 pi over 3, or negative 2/3 pi. All right, one more example here. This is one of our reference angles, isn't it? Remember the 45, 45, 90 triangle. Well, what would that be in radians? Let's see. 45 degrees, we're going to multiply by pi over 180. That ends up being pi over 4. Pi over 4 is the same thing as 45 degrees. So you might see a reference triangle drawn. Remember the 1, 1, radical 2 reference triangle, and you could put pi over 4 in here instead of 45. Doesn't that look kind of fancy then that way, right? Those are called radians. All right, let's convert the other way. Convert from radians into degrees. We have pi over 12 radians, and I need to multiply and get rid of the radians. Okay, so right now, radians, you could think about it as being on top. So I have to put pi radians is the same thing as 180 degrees. And you see that the unit radians cancel. Now, honestly, typically, we don't write the unit radians on our answers. Like up here, if you notice, when I drew my triangle, I didn't put rad there. It's kind of understood that that's it's a radian. Because after all, radian is really the ratio of two lengths. Remember how it was the length of the arc divided by the length of the radius. So technically there's no unit there. It's simply a ratio. All right, we multiply straight across, and we also see that the pi's cancel. So we get 180 divided by 12, which is a tiny angle, 15 degrees is all. All right, moving over here to 5 pi over 4. 5 pi over 4. I'm going to multiply by 180 over pi. The pi's cancel, the unit radians cancel, and I get 225 degrees. 225 degrees. Let me draw a connection here for you. Earlier, we said that 1 pi over 4 was 45. So how many would 5 of those be? Well, if you take your calculator and take 45 times 5, what do you get? 225. 225, they're equal. And finally, we got one more example here. 8 pi over 3, negative. If I multiply by 180 over pi, the pi's cancel. 3 goes into 180 60 times. Radians cancel, of course, leaving degrees. And I get negative 480. Negative 480 degrees. Okay, so just make sure your units cancel and you can convert from either unit to the other. All right, hopefully you found this video useful, and good luck on your assignment. Until next time.